We still have some people joining us, but I think we should go ahead and get started here. I want to welcome everybody and thank you for joining us today. Today we're going to go through the 50 failure modes of motors. We're going to do this with Terry Harris with Reliable Process Solutions. Terry Harris and I am, of course, Gary Moore. I'm with UE Systems, Inc. A little bit about UE Systems. We actually started this company back in 1973. We've got quite a few years in ultrasound. We have a pretty large global footprint. In the United States, we've got 12 of these direct regional support offices, and internationally we have them Mexico, Canada, South America, Chile. It's not on here yet. So, and these guys support an entire host of independent distributors, reps, and the like as well. So we can provide assistance in many places around the world. There's a quick map of where we're at. Seems to be industries everywhere, so we like to spread our wings as much as we possibly can. A little bit about Reliable Process Solutions. They do training and consulting services, really lubrication and lubrication practices, predictive technology, some of the different PM strategies people deploy. They go through these RCM analysis with different people and deploying TPM, and proactive maintenance. Now, in addition to this training and consulting, they built these plug-and-play lube filtration, I guess rooms is the right term for it, but they come in these containers already built, and they're designed to have a turnkey lubrication solution. A lot of that has to do with these electric motors. This is what one would look like. I guess this looks like a 20-foot one. Is one of the shorter ones. When it showed up at your site, you unload it and get it hooked up, and you'd be ready to go. There's an inside shot at one looking at the storage system and stuff that's just really neat and clean. And here's a different shot of one. This is a bigger one. Terry, I'm sure. And Terry, can you hear me okay?
Yes, I can hear you fine, Gary. Let's get started again here. As I was saying, I don't know if you heard me, but as I do RCM analysis, you know, one of the things that come up in motor failures, I ask people why the motor failed, and most people just have the response, well, it locked up or it just failed, but never look at the reasons where there's a number of things we can do to keep our electric motors from failing. If you look at the P-up curve here, which I always show in all my training, it shows how we can move from this reactive area where people are telling us what's wrong with our components by physical contact or hearing noises or feeling things, to where we go over to the predictive area where we can predict failures at an early stage. So a lot of these predictive failures can predict failures in electric motors. And then on the left side of the screen, you know, the proactive things you can do with lubrication, access, precision alignment. You know, select suppliers, just knowing who makes the best motor. And what company I work for, we spend a lot of dollars trying to find the answers to some of those questions. So, and this led me to doing a lot of RCM analysis, which I did after I started my company and still do till today, plus these other training programs on all these things you see on the screen. So, you know, one of the questions I always ask, how long should a motor last? And, you know, there's a number of answers in the industry, all the way from 2 years to 15 years. But we really need to know what makes the motor fail prematurely. You know, in my opinion, as the motto of my company, it can last forever. But in order for components to last forever, we need to understand how those components fail. So if we look at this picture of this electric motor here, you'll see it's got a number of components. You'll see bearings on the front, which people assume that's one of the major failure causes of the motor, and it's only one of them. We see a rotor and a stator. We see windings. We see insulation. We see the housing. And all these components in this motor have failure modes, which will shorten the life of the motor. So in RCM terms, a failure mode is any specific root cause of failure to a component to cause it not to perform its function. So if we talk about different components in the motor, each of those components have a function, and that function has to work in order for this motor to be you know, effectively used in the purpose it's used for. So, you know, looking and counting these motor failures over the years, I put together this article, but motors have over 50 failure modes. There's 8 or 10 major components in the motor, and each of those components have some specific ways they can fail, so it results in 50 different failure modes. So how many of these failure modes do we have control of? And this is one of the things that I want to make clear in the presentation is when you leave this, you can go back and realize that you have control of a lot of these different ways a motor can fail, and if you take action on those and eliminate some of those failures, your motors will start lasting a lot longer. Here's a motor failure breakdown. It shows different ways that motors fail, and you can see on the side over here they've got 51% listed as bearing failures. But we'll look at some things as we go through this presentation to show you why the bearings actually fail, and these bearings are failing for other reasons besides just being related to the motor. So you can see some environmental voltage and load things occurring. You can see some rotor bar issues, which are probably higher than 5%. We can see some stator and winding issues, which may, in my opinion, be higher than 16%, just because of the way motors are stored and used and operated. So a number of different ways in this chart here that they're showing the motor can fail. If we look at motor components, with the different components of the motor, we have the housing, we have a stator, we have a rotor, we have some bearings in the motor, we have some bearing seals, not only on the bearing but on the motor housing itself. We have the bearing housing that the bearing sets in. We have a fan. We have some windings and insulation. We have a shaft, and we have a fan guard. So let's look at some common ways that each of these different components can fail. Now, if we look at failure modes of the motor housing, sometimes you don't think about the motor housing as a failure mode, but improperly installing the motor can lead to some failures of the housing, which in turn lead to failures of the motor. Physical damage of the housing, the way we handle it and store it. Corrosion on the housing can cause some issues, and material buildup on this housing can cause some failure modes to the motor. So we don't a lot of times think about the housing as being a failure mode, but if we improperly install this motor without correcting soft foot in our alignment process, it can lead to failure of the bearings, it can lead to breaking the feet or cracking the feet, and it can even lead to bending the shaft. And for those of you that don't know what soft foot is, if you buy any electric motor today and you set it on a perfectly flat steel plate, more than likely one of the feet on that motor, or maybe multiple feet on that motor, are not going to be in contact with the flat surface. And the reason why is most motor manufacturers in the process of making the motor do not correct this issue before they ship the motor. Toshiba is one of the companies that actually mill the feet off on the motor after the motor's built, which gives you a better motor that actually sets flat on the plate, and you have less of these issues. But different soft foot types. We have the one that's parallel with the foot sets up off of the flat plate. We have the one with the bent foot. And these situations have to be corrected when you do the alignment. Otherwise, we put stress and strain on the motor. If you look at this motor, if we tighten this motor down, you can see on the left-hand side we've got a little bit of soft foot, a little bit of gap there. If we tighten that motor down, we're going to put some strain on the motor, as you can see in the picture on the right. If we look at a motor from the side view and we tighten these feet down, we put some strain, can put some strain on the bearing housings and the shaft. Now, this is an exaggerated example of that, but if we bend the shaft or put 3 to 10,000 strain on that bearing, the bearing's going to have load on it that it shouldn't have, and the bearing's going to fail prematurely. Material buildup on the housing. You don't think about this a lot, and as I go around different plants, whether they're textile plants or oil seeds plants or foundries, a lot of times I see buildup on the motor and product buildup. And I was at a plant this summer in Canada where we took the motor, we read a temperature on the motor in one spot, and we actually cleaned all the buildup off the motor, and I'll show you a picture of that one in a minute. And that motor temperature dropped 35 degrees F. And this is what that motor looked like when we first found it. So you can see the motor's completely covered with product. The fan guard's partially blocked off, so we're not getting that cooling effect, taking the heat away from the housing. And this is going to lead to motor winding failures and insulation failures at an early stage, and doesn't help your bearings at all either. So motor housings need to be cleaned and kept in a clean condition. The motor stator, another major component of the motor. It's the stator core and windings. The stator core consists of many layers of laminated steel, which are used to help create that magnetic field. So how can the motor stator fail? Well, physical damage, and a lot of that happens at a motor repair shop. We can have contamination from the outside by over-greasing. And just today I was at a plant looking at some pictures they took of a motor they opened up, and the motor is completely full of grease from over-greasing, not taking the drain plug out. You can have corrosion due to using the wrong kind of grease, or if you're in a food plant where you're washing down, some of the cleaning chemicals get in there and cause corrosion of the rotor. High temperature is a failure mode of the stator. Voltage imbalance, and this can damage a stator in many ways. Broken supports, and most of the time the broken supports happen with improper rewind and burnout procedures when it goes to the motor repair shop. Here's a picture of a motor that's being rewound. You can see the stator bars and the insulation between it and the windings going in. Nice clean operation here. So what about the one I talked about, stator findings due to rewind burnout? Well, a lot of times we're in charge of this ourselves. We'll have a motor fail. We send it to the motor shop and say, I need that motor back as quickly as possible. And the motor shop's going to do exactly what we asked for, and they're going to use improper procedures to take the windings out. The proper procedures, the motor would go into an oven and be set at a specific temperature, which melts all the insulation off, and the windings can be removed. If we ask for that motor back in as quickly as possible, a lot of times they're taken out with a torch. And when we use these improper heating methods, we can deform and cause damage to the stator, and a lot of times causes the rotor bars to crack by improperly heating the housing in the stator. And also we lose motor efficiencies because maybe the stator is no longer round now. It may be slightly egg-shaped. So rewind burnout procedures at motor shops that don't follow the proper procedures, or if we ask them not to follow the proper procedures, it's going to cause failures of the stator. So here's a normal motor stator and winding showing clean conditions, no visible failures. The only time we could find a failure at this point is by testing this motor with some MCE technology. The rotor in the motor, constructed of many layers of laminated steel. The rotor windings consist of bars of copper or aluminum alloy. They're shorted at each end with shorting rings. How can the motor rotor fail? Well, they can fail due to also the thermal stress and high temperatures, physical damage. Imbalance is a very common problem with motor rotors. We'll talk about that here in a second, but many new motors that I've been in plants where I'm trying to do a precision alignment or a precision vibration to get precision balance, the rotor is balanced from the motor company, and many of them on brand new motors. Broken rotor bars in motors are common, depending on how they were rebuilt or how they're used and how guys are changing bearings in the field. Contamination, again, can cause issues and failures with the rotor bar or the rotor itself, and improper installation. So it's very common to find physical damage on rotors, especially after rebuilds and bearing replacements. Rotor bar surfaces can be damaged during disassembly or assembly. I was in a number of plants over the last couple of years where they detect a motor bearing either with mechanical ultrasound or some tool that tells them the bearing's gone bad, and they're taking major critical motors out of a plant. They're going into the shop and changing the bearings in the shop. And they do this by taking the end bells off. A lot of times they're sliding the rotor out across the stator, not using proper tools and procedures. And we damage some of the rotor surfaces in doing this. So I always say you should not change motor bearings at a plant location, especially on critical equipment. And I've even found plants, which happened last summer, I found guys changing bearings on explosion-proof motors. Well, that motor is no longer explosion-proof once you take it apart in the shop setting and change those bearings. So, you're asking for some major safety problems there. Just a common picture. This is a small motor, but shows the rotor bars and the different components of the rotor in this picture. Imbalance of motor rotors, like I said, is quite common. But if we have imbalance on the rotors, it's going to shorten the life of the bearings. The imbalance, and as the bearings wear with this imbalance, we're going to, eventually we can have contact with the stator and the rotor if our bearings are going bad, especially during the startup and the stopping process. Overheating during rebuild cycle can cause damage to the rotor components. Establish some precision balance standards for rotors of new and rebuilt motors. So if you're buying or if you're sending a motor into a rebuild shop to have it rebuilt, make sure you ask what they're going to balance that rotor to. My recommendation is 0.05 inches per second. There's only one motor company I know of that does that as a standard, and that's Toshiba. They balance the rotors in their new motors to 0.05 inches per second. Have found a couple of those in the field that were off, but not as much as some of the other brands. I've found brand new motors in the field that were 0.28 inches per second in new conditions. So life for those. So something else to check. Motor bearings, in a motor, improper handling and storage, improper installation of the bearings, for doing it in a shop condition, and I've even seen them improperly installed in a motor shop. Misalignment can cause bearing wear. We always want to align all of our critical equipment, especially our critical equipment, to some really tight alignment standards. And those alignment standards, I always try to get to 1/1000ths or 1.5 thousandths in all three planes. And if the motor's in good condition, you can get that condition. Of course, it depends on how good the base is and how much soft foot you got to work with. But always shoot for the best alignment possible. Improper lubrication, we'll talk about that here in a minute, but improper can be over and under greasing. Improper can be the wrong lubricant. A definite wrong lubricant is anything with a lithium base. Lithium attacks metals like copper and brass and some of the soft metals, so we don't want to use lithium-based greases in our motor lubrication. Start-stop processes, and one of the things that happens with electric motors, and I always tell people the only reason the bearings are in an electric motor is to hold the stator off the rotor when it's in a stop condition. And what I mean by that is if you have perfect alignment and you start the motor up, you could actually take the bearings away and the rotor will run in the center of the stator forever without the bearings. So that's one of the benefits of doing precision alignment. But as you start and stop motors, if you have motors that do a lot of starting and stopping, every time you stop the motor, the bearing goes down and the rollers are resting on the race to hold that stator off the rotor. As you start that bearing, there's not very good lube, or as you start the motor up, you don't have very good lube on the bearing, so you get some rubbing action until that motor gets up to speed, until you get the bearing surface covered. So start-stop operations, you do lose the lube film. Contaminated lubes, overhung load is another reason that the motor bearings fail. Over-tightening belts or having the shiv out too far on the end of the shaft. And of course, motor fan, if you lose some blades off your motor fan, you can have some imbalance back there, which will affect the bearing life. So contamination of the bearings from moisture, processed chemicals will reduce the life of the bearing. Most contamination comes from foreign materials in the lubricant that you wouldn't expect, but most of the lubricants, most of the grease lubricants today, those greases are manufactured without a process of filtering the oil before they make the grease, so there are some particles in there. The lubricant goes into the front of the bearing, and most of the time it's just sealing foreign material to keep the contaminants away from the bearing. So, re-greasing motors is a big part of keeping those contaminants off your bearing. Here's a picture. Now, this is not a motor shaft, but you can see it's a shiv on a bearing. In this case here, if we slid this shiv back just 4 inches, we would increase the life of this bearing by 3 times. So the same factor goes when you're putting a shiv or a sprocket on a motor. Keep that as far back as you can and still get a guard on there, but keep it as close to the motor bearing as possible. And that will extend your bearing life on your motors greatly. So make sure motors have the correct bearings for the application. And I was thinking this was getting more common, but I was talking to some oil seeds people just a few weeks ago, and they were having some trouble with bearing failures on some motors, on some flakers. And what happened, I asked them if they ordered the bearings that were, or the motors that were set up with roller bearings in the front, and they didn't know what I was talking about. But if you're going to buy a motor and you're going to put a shiv or a sprocket on that motor, you need to let the motor vendor know that, because that motor will come with roller bearings in the front instead of ball bearings. So it's just something that I don't think vendors make the knowledge as available as it should be, but you have to get the right kind of bearings in that motor if you want to get the long life out of that motor. Always use the correct lubricant. Like I said, don't use lithium-based greases. Don't use your standard general purpose greases. All your motor greases should be a polyurea-based grease, or they should have some kind of a symbol on there that they're EM rated for electric motors. There's a lot of properties in these greases that make them more user-friendly for motors, so make sure you do that. Make sure you use the right grease. Now here's a picture of a motor that's been over-greased. You can see grease in the windings. You can see an over-greasing failure in the upper right-hand picture where the grease got in there and had a short out, and we burnt the windings, or the grease caught on fire. So we have to make sure we use the right grease and we don't over-grease. Now, one of the things that I always tell people when they're greasing motors is you always have to take the plug out of the bottom. So you grease, you force the old dried grease out the bottom, and so I always recommend you take the plug out. Now, taking the plug out when the motor's running can be a safety issue. So they make these little small relief valves here. The one on the right is one you would put in the bottom of your motor in the plug area. It's a small relief valve that releases at 5 to 10 psi. Will keep you from over-greasing the motor. And these are standard on like Toshiba motors and some of the Reliance motors now. This pressure relief is standard. That eliminates the over-greasing. The one on the left is a grease zerk with the pressure relief in the top. I don't like these as much because I like the ones on the bottom where it forces some of the old grease out. And then, of course, as the grease sets in the motor and it heats up, a lot of the greases, the oil and the soap binder will separate, so you'll see some dripping, which is another indication that you should replenish that grease on a regular basis. And there's a number of articles out there on motor greasing relube frequency. But this is another good application for UE's tools, the grease caddy or the grease the 9,000 or 10,000, where you can actually listen to the motor bearing and know when it needs some grease or know when it's short of grease, and do your lube cycle, lube regreasing cycle with those tools. Motor bearing seals, you know, they fail a lot of times. These can be the seals on the bearings or the seals on the front of the motor housing. They can be improperly installed and damaged. If we look at this motor and we can see the grease zerk on top and we can see the pathway down, all we're really trying to do here is fill up that void in the front of this bearing here, and that keeps contaminants, moisture, and other things from getting to our actual bearing. Most of the time, in 80% of the cases, the front of this bearing has a seal on it anyway, and we're not really greasing this area to get grease into the bearing. There's some available there if the bearing gets hot, but the majority of the time it's there to keep contaminants and moisture out. So that's a good reason to have a motor greasing program and replenish that grease with fresh grease. The motor fan, physical damage to the motor fan. I've been in plants where the back of the motor is built up with ice. I was at a plant one time where the water had dripped on the fan and the ice was built up, and when we started it, all the blades were ripped off the motor fan. I was in a plant where it's way too cold for humans to live, but they actually had a plant there. But foreign material buildup on the housing, we looked at that. Corrosion. A lot of the fans I see on motors are aluminum. I've seen those corroded and the blades completely gone. But that motor fan's there for a reason. It's there to have that cool air across that motor. It's there to keep the temperature down on the motor and the windings. And so we have to keep these fans free and open. I would say over half the plants I've been in, the back of this motor here is covered with, let's say, polymerized vegetable oils. It's covered with materials like this that are dirt and dust. I've seen it covered with textile material in textile plants. So this is part of a regular PM of electric motor to keep this fan clear and keep that motor clean. And then it'll extend the life of the motor many, many times. Motor fan guard, and this goes right back to what we talked about. Keep it clean. Keep the holes from plugging, and this will eliminate some major failure modes of your motor. If we look at the motor insulation and windings, we got failures due to contamination. We talked about that earlier where we're pumping grease. We get cleaning chemicals in there. Overheating, running at too high a temperature is going to shorten the life of the insulation and the windings. Improper storage. When I ran a plant, one of the things we found out when we ran an MCE test on all of my spare motors was about 40% of those motors wouldn't have lasted a year if I put them online. It was due to the fact that we were storing them in an outside non-ambient controlled building, and those motors being stored outside, and my maintenance guys taking those motors out and putting them into a warm area and starting them up, we had moisture that was in the windings, and that those were causing some of our failures. Moisture, we should have taken them inside, maybe ran them without any load and dried those windings out somehow before we put them in. So if you can, store your motors in an ambient controlled area and control that moisture that can get in the winding. Insulation breakdown due to temperature, due to cycling and flexing, starting and stop operations. AC drive stress a lot of times with your pulse modulated drives cause some stressing and flexing for your insulation and windings when we'll eventually have wear spots and short those windings out. You know, a real good point here, you know, the life of the insulation in a standard electric motor is based on the temperature of the motor that it's going to operate in. So the insulation life is cut in half by every 18 to 20 degree rise in temperature. So if you have motors in your process that are running at 120 or 160 degrees in the operation, you know, the life of some of the windings at that temperature is going to be down, you know, below 2 years. And if the motor's running 160 degrees, it's going to be down around 1 year. So we have to make sure we maybe order a motor with a better winding, better classification of insulation. But in most of the studies I've seen, the better insulation will extend the life, but you only gain about 20% more life. So that's why it's key to keep the motor clean, keep some good airflow across the motor to get rid of that temperature. And I even had a couple of plants where we actually brought some outside air in across some critical expensive motors to keep the motor cool, or find some cooling media to cool it down with the fan. So, but you can use this light factor and look at some of the motors you have in your plant and see how that compares with some of the life you're getting on your motor insulation and your winding failures. You know, insulation breakdown a lot of times can be found with many ways. We can do it with MCE. Testing will tell us if our insulation breaking down. Testing, here's a picture of a motor with a thermographic camera, and we can see a hot spot on the side of this motor that's developing there. I mean, that could be a number of things, but it also could be, you know, at a turn of a winding. We've got some heat buildup there. So, you know, the thermographic camera is a good predictive tool to look at some of these failure modes. And we may also have a hot bearing here that is going to shorten the life of this motor. Here's a winding shorted turn to turn in an electric motor. You can see the shorted out area here in this motor. And you can see here it can be caused by contaminants, abrasion, vibration, or maybe a voltage surge. Cycling and flexing of the insulation and winding occurs from frequent start-stop operations. I remember watching a demonstration or a presentation put on by one of the MCE companies, and they had a slow motion picture of the windings actually flexing during the startup. I mean, it all happened over about a half a second, but you could see the windings in the insulation flexing during the startup and shutdown cycle. So these over time with a lot of startups of motors can actually wear holes in your insulation. Motor shaft, you know, physical damage of the shaft, improper manufacturing, improper installation either by maintenance or the motor shop, corrosion a lot of times from the way they're stored and the way they're operated. I've seen a number of motor shafts that were corroded underneath the bearing surface, and the bearing edge of the bearing housing had corrosion. So here's a motor shaft. We won't spend a lot of time on this one, but this is a major failure of a motor shaft. I'm not sure exactly how this could have happened, but you know, this picture was online and available, so I thought I'd put it in the slide presentation. But looks like this bearing got excessively hot enough to melt the shaft and bend it. But that's a little excessive. You won't see many of those in your lifetime. So some preventive maintenance for motors. I put some preventative, some predictive, some proactive steps in here to help our motors last longer. You know, the first one is preventive maintenance. You know, grease motors as needed on the service that they're in. You know, if a motor's in a real hot area or if the motor's running at a really high temperature, that motor's going to need lubricated. The bearings are going to need lubricated more often. And you're going to have to develop some procedures and look at that. You know, the load of the motor is going to depend on how often that the motor is greased. If you want some information on that, I do have some information and slides that look at different size motors, different frames of motors, and different operating conditions and how often they should be lubed. If your motor bearings, you have big motors that are lubricated with oil, you know, I always recommend here you change that oil based on temperature. If any of you listen to my 50 failure modes of lubricants, you can see that lubricants follow about that same failure pattern with temperature as we talked about for the motor windings. You know, at 70 degrees, that oil will last for 30 years, and life is cut in half for every 18 to 20 degree rise in the oil. So this oil is going to be changed based on temperature, but definitely do an oil analysis on it. I was at a plant in Singapore where they the oil looked good in the glass, so they weren't changing it on some big sleeve bearings. When we pulled the sample, the oil was highly contaminated with very small particles under 10 microns. So they were getting a lot of wear on those bearings, and the bearings were only lasting about 16 months, where they should have lasted 5 to 10 years. And I always tell operators as they go around, perform some hands-on inspections weekly on your electric motors. You can feel early signs of vibration. You can feel temperature changes. You can keep the fan guards clean. So we got good airflow across the motors. Storage of motors, like I told you the story, what I was doing at my plant, we were storing them outside in an outside building. We were in Ohio, so we had negative temperatures in the winter and temperatures in that building well over 100 degrees in the summer. So not very good conditions for storing motors. And then of course keep moisture and chemicals away from your motors. And plants that do a lot of wash down and a lot of cleanup, you got to keep that moisture and chemicals away from the motors and the motor seals. Some precision maintenance techniques or tips for motors. Always align your motors to at least under 3 thousandths in all 3 planes and eliminate soft foot. You saw the pictures of what soft foot can do to shorten the life of our motors. Always specify precision balance when you're rebuilding the motor. Specify to 0.05 inches per second. Very good practice, and you'll see some extended life on your motors doing this. If you're buying new motors, like I said, there's only one company I know of that balances below the ESA standard, or the ESA or ANSI standard. The ANSI standard is 0.08 to 0.12. Toshiba does balance the rotors in their motors down to 0.05 inches per second. And like I said, I've seen brand new motors delivered to a plant and had them checked, and the vibration was 0.28 on 2 of 4 brand new motors. So it's something that's very important to motor life. Use certified motor rebuild shops for all your motors. If you're just sending your motors to get rebuild, stop into that shop and look around. Make sure that the shop's clean. Make sure they're following, some written procedures and guidelines on how they rebuild those motors. Ask them to buy some MCE gear MCE equipment to make sure the motor's good when they send it back to you. And then, of course, the decision to buy or rebuild the motor is always a decision. I've been at companies, you take companies like Cargill, and a lot of companies, any motor under 50 horsepower or 75 horsepower, they don't rebuild them. One of the main reasons for that is because of some of the shoddy work we get out of motor rebuild shops. These motors can be rebuilt, and we can get long life of the motor if we just know what questions and what recommendations to put on our motor rebuild shops. Predictive maintenance, motor circuit evaluation can detect nearly all motor failures. Vibration analysis can detect motor failures. Mechanical ultrasound can detect failures in bearings, the rotor bar, and a number of electrical failures. And it's an easy tool to use, the 10,000. Now we can record this data and watch these failures trend over time. So excellent tools for motor bearings. If you have sleeve bearings with oil reservoirs on them, make sure you're doing oil analysis and wear particle analysis on those specific motors. Some other things with ultrasound, mechanical ultrasound primarily detects bearing failures. Failures that tend to appear first in the bearings. But ultrasound's becoming more and more popular for the bearing failure prevention with over and under lubrication. It's an excellent tool to know how much lube to put in and when to lube. So that I think if you talk to the guys at UEs, they're doing a lot of studies on those, and there'll be a lot of good information coming out at their conference in May. Bearing failures due to electrical arcing are things you can pick up with the ultrasound tool. Ultrasound tool, I have been used to detect rotor bar problems in electric motors and many other motor issues such as rotor imbalance. Lineman and softfoot's another thing that UE can detect with their equipment. So, very good technology. To have a UE tool at your plant to check all the other things that you can use with UE motors it just adds to the benefit of having that tool. On motor rebuild, every time a motor fails, the decision must be made to rebuild that or buy a new one. Motor decision chart helps us guide us through that decision process. If you're interested in one of those rebuild charts, I can send you one of those if you shoot me an email. But it's a good tool to use for making that decision or help you make that decision. And then proactive things for motors. Purchase precision motors for critical applications. And I always tell everybody I don't recommend that you go out and buy a Toshiba motor for every application. But if you have critical applications that have high downtime costs, I recommend you buy the better motors. Use certified motor rebuild shops that have specifications. That way you get something back that's closer to new condition and long life. Make sound decisions on to rebuild it or buy a new one. Use precision maintenance on all installations. Make sure it's aligned. Make sure you get rid of soft foot. Make sure you get some good alignment procedures. You may have to change the base that you're mounting on to do that. Make sure you have good balance standards on the motor, and make sure definitely have good lubrication practices and you're using the right lube. So that concludes my presentation. I'm hoping there's some things in there that'll help you make your motors last longer life cycles. And with that, I'll open it up to Gary for anybody that may have a lot of questions, or you can send the questions to my email.
Back here on this thing is other opportunities from UE Systems. Thank you for the other things we do there. Along with electric motors, of course, this ultrasound very often gets used for things like leak detection, steam traps, or electrical as well. UE Systems does an awful lot of courses just like yourself, Terry. We do ones very specific on steam. We do level 1, level 2 courses and things like that. You can always get to our website to go see our schedule. And you had mentioned a little bit earlier, so we're going to do some more webinars this year. Maybe we'll get you to do some on lubrication. Terry, we're getting an awful lot of questions on that online here. We'll get back to everybody just as fast as we can. They're overrunning us a little bit here. If you want to get a hold of us, you can get us at uesystems.com. Call us toll-free on this 800 number, 800-223-1325, or you can get us on the local numbers if you're calling out internationally. You can always email us as well. A lot of information up on our website. Again, if you're looking for Terry or the guys at Reliable Process Solutions, it's tkharris10@hotmail.com. There's his phone number and his website as well. A ton of information that you can get out of Terry when you can catch him. Of course, he's out working a ton, so you got to be mindful as you send him off emails and things that it might take him a little bit of time when he gets free from a plant. We are recording this, so it will be available up on our website after the fact. If you want to show this presentation to somebody else, you can certainly get up on our website. Up there is previous webinars, a couple others we've done with Terry and other people in industry with different specialties and different information they can get for you. UE Systems likes to continually try to help bring new information out to the customer base to see how it can help people make plants more efficient, wear longer, last longer, make people into really good operators. So take a look on the website. I'll send everybody a link to this webinar once we have it up and recorded and available to us. And with that, that's about all I really have to say. We'll get back to these questions we have coming up on here. And so sorry for the delay. We couldn't get to them fast enough, but we will go through all the questions and get you answered in time. Terry, thank you again for your time. I know that we're taking time out of your busy day when you're in there working to kind of share some of this information, but it's great. So with that, I think we'll end the webinar here, and we look forward to seeing you again probably in January. We'll be announcing another one. Thank you.